Problem 35 here is asking us to use Theorem 1 to verify one of the 6 trig derivatives that we were taught here in section 3.6. And boy, you guys, Calc students in general, do not like the word verify because it basically means the same thing as the scariest word you've ever come across in your math studies, which is prove. So we're basically trying to show here that the derivative of cotangent of x is equal to the opposite of cosecant squared of x. And of course, you can't just say, well, it's true because my teacher wrote it on the board. That's not what the word verify means. So Theorem 1, I had to look it up. I wasn't sure what it was. And then I said, oh yeah, this is just where they teach you in the book the 2 basic trig derivatives, that the derivative of sine of x is cosine of x, and that the derivative of cosine of x is the opposite of sine of x. So we can use those 2 pieces of information in order to try to prove the derivative we're trying to verify here. So what I would probably do here, guys, is take this right here, take the derivative with respect to x, and rewrite cotangent of x in another way. Cotangent of an angle is cosine of a particular angle, I should say the same angle, divided by sine of the same angle as well. And the reason I think it benefits us to rewrite cotangent that way is that we can use Theorem 1 now because we know the derivatives of both sine and cosine. So the derivative of a quotient is going to require the quotient rule. And here we go. Bottom, which is sine of x, multiplied by the derivative of the top. Derivative of cosine of x is negative sine of x. Now, if you're a little sharper than I was right there, you might have written that a little more efficiently in one step, but I'll get to it in the next. So that's bottom times derivative of the top minus the top, cosine of x, times the derivative of the bottom, and the derivative of sine of x is cosine of x, all over the denominator, sine of x squared. So we'll write that as sine squared of x. And what does that do for us, guys? Up in the numerator now, we have sine of x times the opposite of sine of x, so that is the opposite of sine squared of x, and then a minus cosine squared of x all over the sine squared of x again. And boy, every time I get to talk about this, every chance I get, I'm going to do it. You cannot cross out the sine squared here and the sine squared here and be done, everybody, because this is not a factored expression. You can only cancel out factors from the top and the bottom. Sine squared of x is actually a term. It's being added or subtracted. So, where do we go from here? Because it really doesn't look like we are here just yet. Now, we're actually not that far away. In the numerator here, guys, you'll notice that both those terms are negative. So, if I were to pull out a negative 1 in the numerator, that would now give us positive sine squared of x plus cosine squared of x, again, all over now the sine squared of x in the denominator. And let me move things around here just a little bit. Okay, got it. So where are we now, guys? At this point, all right, I'm hoping you recognized as soon as I did that, that whole binomial quantity in the numerator, sine squared of any angle plus cosine squared of the same angle, is always just equal to 1. So my numerator is now negative 1 times 1, which is just negative 1. My denominator is sine squared of x, and sure enough, 1 over sine is cosecant. So this expression becomes the opposite of cosecant squared of x, and that, of course, is the derivative that we know and love, that we were taught anyway, for the derivative of cotangent. So negative cosecant squared of x, that is how we verify that trigonometric derivative.